Hi, my name is Tejas Ramani. This is my video lab report for Lab 1 in Physics 2211. In this report, I will introduce the investigation of constant velocity. I will show a video of the experiment analyzed with the tracker application. I'll show the code that created a model to predict the position of the object. I will compare the results of the tracker and the model, and I will answer the questions what if and what does it mean, and I will give my conclusion. These are some relevant laws to this lab. They include Newton's first law, which is an object at rest tends to remain at rest, and an object in motion tends to remain in motion with a constant velocity, unless it is acted on by a non-zero net force. And Newton's second law, if there is a net force acting on an object, the object will have an acceleration and the object's velocity will change. Some relevant formulas that I used in this experiment were the following. I used them to calculate the position, final velocity, and to relate force to acceleration. Note that friction is not included in these equations, which is later mentioned as a source of potential error. This is a rough free body diagram of the forces that exist on the object. The force of gravity, a normal force off the surface, an applied force, at least initially, and friction. So in this lab, we prove Newton's second law / the momentum principle. We accomplish this by comparing an experimental model with a computationally derived model using GlowScript. So for the lab setup, I used an Aquaphor lipstick chapstick, of measurements 4.8 grams and 2.030 centimeters across in diameter, and I pushed it across a flat surface. I recorded this and uploaded it to Tracker to get the position versus time and velocity versus time graphs. I calculated the initial velocity using the formula delta r over delta t and calculated it to be this following vector, and the initial position based on the tracker results is this following vector. This is the motion of the object. So this code shows the mass of the object, the initial position vector, and the initial velocity vectors, which were calculated using these formulas and given the data from Tracker. This code shows that this experiment continued up to 1.733 seconds, which is how long it took for the chapstick to remain on the screen. These are the graphs that resulted from the GlowScript experiment. As you can see, position versus time is linear increasing, and velocity versus time is a constant. This is the observed versus calculated position versus time graph. As you can see, they're not exactly the same, and some reasons for these discrepancies could include human error, friction, camera distortion, and unusual shape of the object, which is a cylinder, which could have caused the motion to be slightly different than expected. What if we flip the axis? If the x-axis were to be flipped, then the slope would become inverted as the position changes at the same rate but in a different direction. What does it mean? In reality, there is friction, which wasn't included in the model, but it would eventually lead the chapstick to coming to a halt, so net force isn't truly zero. Otherwise, the chapstick would continue to roll forever until something stopped it. There was velocity from the initial push on the ball, but it is impossible to determine how many pushes or pulls there were. So in conclusion, an object with net force 0 has a constant velocity, proven with a computational model, the Tracker application, and Newton's second law. Thank you.